Hi everyone, welcome back to my channel, and today in this video we are again going to continue our system design playlist video, and in this video we are going to study the new chapter and we are starting with database replication. So in this whole chapter, like, there are going to be around 4-5 videos where we are going to cover about database replication, how it actually works. We are going to study about the architecture. We will also see about leader election, quorums, and how commit types work. So there are going to be a lot of topic in this whole chapter. Again, it is going to be the part of the system design topic playlist. So without wasting any time, let's get started and study. What is replication? So replication means that suppose that we have one database, and what we are going to do, we are going to make copies of the database. Okay, so let's say this is my primary database and we are going to make copies of that particular database. This is known as the replication. So it means that if this database has for example, let's say if database has 100 rows, so this will also have 100 rows, this will also have the 100 rows. These are the exact copies of this primary database. So replication means that we are going to make copies of the primary database. Like, I hope you understand the definition of database replication. Now let's talk about that why we need replication. So the simple answer is, if there is going to be one server, it means that if the one database is running, then there is a high chance of a single point of failure, that I mentioned it here. One point of failure, that is single point of failure. If it is crashes, your app will go down. Okay, so our servers, like our services, are going to connect to the databases, and if our database will crash, the whole app will go down. The thing is, because there we have only one database, but if we make multiple copies of that particular database, then we'll able to save our data and our app will not go down. So this is why we need replication. So there are three main benefits of the replication. The first one is the high availability, read scalability, and the low latency. Let's discuss them one by one. So first one is the high availability, because we have multiple copies. So what will happen if I draw again? So we have now three database, we have one primary and there we have the two replicas, or we can say there we have the three copies of the data. Now what will happen? Let's say if this one crashes. Okay, for example, this database crashes, so we don't have to be worry because if this, oh my god, there is some issue happening. But yeah, if this database crashes, we don't have to worry, because these two databases are still there and they will have the same data and they can still be available and they can still provide the data. They can also handle the write operations in some cases, that we can say that our system is highly available in that case. Second is the read scalability. Okay, so saying is, if this particular database crashes, okay, we can still read from this database and we can still read from this database. Okay, so we can say that our system is read scalable. This is what database replication is providing. Third is low latency. If the user is in India and get data from the India server and not from the New York server, that I write it here, but I'll explain you with this diagram here as well. Like, assume that this is a world, and now what we can do, we can make these replications. Okay, so I'll make one replication here and one replication here. Suppose that the request is coming from this side, then we will lend the request to this replication. If the request is coming from this side of this world, then we will lend the request to this replication. Okay, we will choose the nearest replication, we will choose the nearest data. For example, if the request is coming from India, we will choose the database near India, and if the request is coming from New York, then we'll choose the database near New York. This is what we want to achieve. Okay, so we've discussed all this point. This is how we are ensuring the low latency. That is why we need database replication. Now, there are three architecture types and three commit types in our database replication that we are going to study in our next video, but we will just see what are these things. First of all, let's discuss what are architecture types. So architecture type discuss about how nodes are placed, basically how master is placed and how replicas are placed, and secondly, who is going to ensure the write operation. Here also we discussed about the read scalability, we didn't talk about the write. So that's why we are now going to discuss in the architectures who is going to ensure the write operation. Okay, that is why we have the three architectures in our database replication. The first one is the master slave. In the master slave, the master is the one who is going to ensure the write. So it means that the write operation will take into the master first and then the replicas. It means that replicas are going to be synced with the master after some time. Okay, it can ensure that after some master, it will ensure that after some time I will just send the data to the replica so that they can be in sync. Okay, because master and the slave should have the same data. Okay, so either the master can send the data into the sync or master can send the data asynchronously. Okay, we'll discuss these things in the commit type. But the thing is, the write operation is going to happen into the master. This is the important point in our master slave operation, master slave architecture type. Secondly, we have this multi-leader. In the multi-leader, what we are going to do is that we are going to have multiple masters, and these masters are connecting with their own replicas. So for example, this is our New York server, or this is our India server, and we have their India replicas in India, we have the replicas in New York, and these masters are also syncing with each other. There are some protocols that we are going to study when we are going to deep dive into this multi-leader replication, how these masters are going to be in sync. Okay, we'll study about that. Third is the leaderless replication. Replication, what happens that the user will send the request and any of the replica can act as a master and take the write operation. Any of the replica can act as a master. So what we usually do, we usually use this type of leaderless replication in Cassandra or DynamoDB. We usually use quorum in it. For example, whenever user send a request and we have 4 replica, we can ensure that the write is a proper write when we send the entry to the 3 replica. Then the 3 of the replicas will say that we have this particular entry inside our database, then we will say that is a correct write. Okay, out of 4 we say 3 is a proper write. Okay, so this is known as a quorum. We can make any logic. Let's say if the 2 of them says that we got the entry, then we can say that is the proper write, and after that, if these 2 have the proper entry, they can sync with replica 3 and replica 4. Okay, so this is known as the leaderless replication. The point is any of the database can accept the write, and let's say 2 of them accept the write, then we can say that it is a complete write or a proper write. Usually we use it into our Cassandra and DynamoDB. Multi-leader and the master slave architecture we use in Redis, MySQL, Postgres, very commonly used in all of them. Now let's understand the commit types. So there are 3 types in commit. Okay, first is synchronous, asynchronous, and the semi-synchronous. These are quite commonly used everywhere. So for example, the synchronous one is very commonly used in banking systems. Asynchronous one very commonly used in, let's say, social media application or the feed application. Semi-synchronous one we can again use in social media or, like say, e-commerce sites. We can use it anywhere according to the requirement of the service. So first of all, let's talk about the synchronous one. In the synchronous one, what is happening? If the master is sent, the request is coming to the master. So master will not return back to the server directly. What it will do, it will send the request to the replicas, both the replicas, and when the write is complete in all the 3 master and all the 2 replicas, then we say that it is a synchronous write, because in all the 3 everything is in sync. We say the commit is possible only after it is in all the 3 databases. Okay, so this is known as the synchronous. In asynchronous one, what happens? Whenever the server sends a request, master instantly return. Master will return instantly, and later with the help of any cron job, with any scheduler, or with the write ahead logging, it will sync with replicas. So replicas will get the data with the help of any one of the technique. The replica will get into the sync after some time. So in asynchronous one, what happen usually, we'll get the data but after some time. So for example, let's say if you are using a social feed application like Instagram, if you press a like button, so maybe after some time a person who is sitting in New York will see your like. Okay, because it is going to be replicated to their databases, and after some time you will get it. But in a synchronous application, what is going to happen? Let's say you are using a banking system. At the same time, when the money is deducting from your account, it is going to be added to the another person's account, because it is in sync. Everything is going to be updated in one go. This is the synchronous and this is the asynchronous one. Now comes to the semi-synchronous one, in which what happen, let's say there are 3 replicas and we have one master. Now what is going to happen? We can make any analogy right now here that we will consider a write whenever a master will receive the write and any one of the replica will receive the write, then we will say it is a perfect write. Okay, so what happened? Let's say if the master will go down, then we know that replica 1 has the updated data. Okay, so for example, this master will go down, any situation occur if the master goes down, so we know that we can make replica 1 as a new master because replica 1 is the most updated one, because these replica 2 and replica 3 will again, like later, I mentioned later, so they are going to be updated with the help of the write ahead logging or any other technique. But the point is, this replica 1 will become the new master because if master goes down, and we will consider the write when one of the replica and the master is going to be updated. So this is known as the semi-synchronous one. We can also make, let's say, instead of one replica, we can say that, we can also say that if the two of the replicas and the master will get the write, then we will consider it as a proper write. This is known as the semi-synchronous one. So these are the 3 commit types. Okay, and these are the 3 architecture patterns that we have discussed in this video. In the next video, we are going to study about the master slave architecture, or you can say leader follower architecture in detail. So thank you for watching me, and we will meet in our next video, and have a good day. Bye bye.